In 7.5, we're going to learn about scale drawings and models. A scale model is a 3D drawing of an object. You might see this as an architect builds a building. A scale drawing is just a 2D drawing of the object. Both are proportional. The scale is what actually gives the ratio that compares the measurement of a drawing or a model with the actual measurements of the object. So, for instance, a drawing distance could be 1 inch, and in reality, the actual distance could be 10 miles. You might see this on a map. Here is an example of a map or a 2D scale drawing that is going to ask us how to find the distance between Cadillac and Detroit, Michigan. So the first thing I want you to draw attention to is on all maps, there is a scale that tells you how to figure out the real actual distance. So up here in the corner, you'll notice this is our scale. So it's saying for every centimeter on the scale, the drawing, you're really going 50 miles in reality. So the first thing that we need to do is get a centimeter ruler to find the distance on the map between Cadillac and Detroit. Okay, here's Cadillac and here's Detroit. And if I would draw a straight line, I'm going to find out that the map distance is about 3.5 centimeters. Okay, so I'm going to use the scale given and what I know about proportions from chapter 5, and I'm going to figure out the real actual distance. So I'm first going to write down the scale is 1 centimeter for every 50 miles. That's what this tells us. And I know that I've gone 3.5 centimeters. So the question is, how many miles is this? So what's my distance, my D? Okay, so then there's a variety of ways you can do this. I would do cross products. Okay, and I would take 50 times 3.5 to get my D, because D is just times 1, so that's really just D. Okay, so if I take 50 times 3.5, I'm going to end up with D equals 175 miles. Here's another example with a model. Pretend the picture to the right would be an actual model, maybe in a science classroom, similar to a globe. It says the liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layer of the Earth has a scale of 1 inch equals 500 kilometers. So how thick is the liquid outer core of the model? So the first thing I'm going to do is write down the scale. 1 inch equals 500 kilometers in reality. 1 inch on the scale versus 500 kilometers in reality. And it says the liquid outer core of the Earth is 2,300 kilometers. So they want us to know how thick that would make it on the scale. Okay, so this is my X inches. And that's what I'm solving for, is my X. So you can do cross products. So I would take 1 times 2,300, which is just 2,300, and then divide by 500. So 1 times 2,300 divided by 500 is going to give you 4.6 inches. So that is your answer. Okay, again, you just set up the equation like we were solving a proportion, because we are, and then use your cross products to solve for the variable that's missing. So far, we've used 2 different scales. We've used the scale from the map of Michigan, trying to go from Cadillac to Detroit, and that scale was 1 centimeter to 50 miles. We also used a scale for the model of the Earth's crust, and it had the scale of 1 inch equals 500 kilometers. Okay, but if a scale can be written, notice they're units because it's similar to like a unit rate. I have 2 different units. I have centimeters to miles and inches to kilometers. But what if I want to write the scale without units? A scale can be written without units when the units are the same. A scale without units is called a scale factor. So how do we find a scale factor? So let's have an example there's this monument that gives you, let's think of a monument that is really 100-foot tall. But on the scale, on the model is only 10 inches tall. Okay, so the monument's 100-foot tall, and the model of the monument is 10 inches tall. Okay, so let's write this as a ratio. Okay, so model height is 10 inches. The actual height of the monument, we said, was 100 feet. Okay, the first thing that I would do is try to simplify the 10 and the 100 if I can. Okay, so I can cross out a 0 there and cross out a 0 there and end up with 1 inch to 10 feet. Then I'm going to look at that and see how I can convert it to where they have the same unit of measure. And right now I'm working with inches and feet. So I'm going to go and I'm going to convert this to inches. Okay, so I'm going to keep the 1 inch. That's already inches. So I'm going to keep that 1 inch. Okay, and I'm going to convert the 10 feet to inches. Well, I know that there are 12 inches in 1 foot. So I'm going to take 10 times 12, and I'm going to get 120 inches. Okay, so my 1 inch to 10 feet got converted to 1 inch to 120 inches. So because now I have the same unit of measure, I can just say that my scale factor is 1 and 1/20. You can also write that as any type of ratio, often seen as 1 and 1/20. So that is my scale factor. And all I did was simplify first if possible, and then I converted it to the same unit. And because I was working in inches and feet, it just made sense to convert my feet to inches. The last thing that 7.5 wants to teach us is how to find the actual perimeter and area based on a scale drawing. So here is a scale drawing of a computer chip, and it has the scale of 1 centimeter to 2 millimeters. When we measure using a centimeter ruler, the scale drawing of the computer chip has the side length of 4 centimeters. So the length of it is 4 centimeters. So if I'm just keeping to scale, if the side length of this square is 4 centimeters, that means all 4 sides are going to be 4 centimeters. So to find perimeter, I add all the sides together, so 4 plus 4 plus 4 plus 4, because all 4 sides are 4 inches, 4 centimeters. So that's going to give me 16 centimeters. Okay, to find area, I take length times width. Okay, 4 times 4, and it just happens to also be 16 centimeters squared, because area is always squared. So that's for my scale. So let's look at that, and let's determine how we're going to find actual perimeter and actual area of the real computer chip. 1 centimeter is 2 millimeters. So we're actually getting smaller, and we're going to get a smaller version. The real computer chip is smaller than the scale, or the scale drawing. Okay, so our scale is 1 centimeter to 2 millimeters, and I know that one side is 4 centimeters long. So what is the side of the actual one? Okay, so I can do cross products, and I'm going to end up knowing that the side is 8 millimeters in length. Okay, so again, knowing that my side is 8 millimeters in length, I can take 8 plus 8 plus 8 plus 8, which is also just 4 times 8, because it's a square, so all 4 sides are the same length. And I'm going to get my perimeter being 32 millimeters. Okay, to find area, knowing that my side is 8 millimeters, I'm going to take 8 times 8, because both sides are the length and the width are the same distance. So 8 times 8 is 64 millimeters squared. Okay, so to find perimeter and area, I really didn't need to find this. I just did that to kind of show you how we were doing it. What I really needed to do was just figure out what my actual side length is based off of the measure of the scale and using the scale as a proportion. And once I've done that, then I could just use my prior knowledge about perimeter and area to find out what my answers are.